All right, welcome back. And today we are going to do a question called sorted square numbers. Let's look at the question right here. So here it says, given a list of sorted numbers, can be both negative or positive, return the list of numbers squared in sorted order. Here's an example and some starting code. This is the starting code. Solve the problem in linear time. So the question here is, basically, we're going to get a sorted list and we're going to have negative numbers and positive numbers. And then what you have to do is you have to return them the squared numbers. Now, this question is extremely easy if it were only positive numbers, right? Because if it's only positive numbers and the array is sorted, then that means it's just going to be already a sorted list. All you have to do is multiply by themselves, aka square them, and then there you go. There you have it. But the thing is, for negative numbers, if you choose to square them, they become positive. So that means the negative numbers might be bigger than some of the positive numbers that are smaller in terms of absolute number, right? So in some sense, you kind of just have to order them in terms of their absolute value, so you don't care if they're positive or negative. All right, let's go to the iPad and look at this problem a little bit more closely. So now we have the same numbers. We have -5, -3, -1, 0, 1, 4, 5, and then the sorted list is going to be these numbers, right? And then if we look at them, then we can see that -5 becomes 25, -3 becomes 9, and -1 becomes 1, right? So as you can see, they are kind of like intertwined with each other. And then for the positive side, 0 squared is 0, 1 squared is 1, 4 squared is 16, and 5 squared is 25. So in some sense, that's how you have to move them along. Now, the question is, how do you do that? There is a brute force way where you can just square all of them and then you sort them, right? But that would be kind of like an n log n algorithm because you still have to sort them. But there is one great thing is that this array is already sorted. The only thing is that one of the sides are negative. So intuitively, what you can think of doing is you could think of reading it this way and that way, right? So first, this is the point where it becomes positive. So actually, let me draw the arrow like this way and that way. So what you can do in an intuitive sense is you compare these guys, right? 0 is definitely smaller than, let's just say absolute value. 0 is definitely smaller than -1 times -1. So we have 0. And then we got this guy now, 1 and 1, they're the same. So this guy goes here. And then now -3 versus 1, 1 is smaller, you get 1. And then 4, and then 5, 5, right? Okay, so how are we going to do this in terms of, to make it a little bit more efficient? So essentially what you want to do is you want to go to the point where it is from negative to positive and then just move, right? And how we're going to do that is we're going to use a stack in the beginning. So what you want to do is you have a stack and then you're going to go through the negative numbers, right? So in your algorithm, you'll start here and then you'll put the -5 here. Oops, that looks like a 3. -5, and then you see -3, and then you see -1, and then that's pretty much it. That's all the negative numbers you have, right? So now you still haven't popped in anything yet. You've just only put all the negative number into your stack. Now that we have a positive number, we see if this positive number is smaller than the stack, the top of the stack. So -1 times -1 is 1, 0 is 0. So there you go. So your answer will be here, okay? You'll get 0. So we're done this. And now you're pointing at 1. You compare with 1. Let's just say 1 is smaller. It's actually equal. So you have 1 here. Now you're at 4. And then 4 you compare to -1. -1 is smaller. What's -1 times -1? This guy would be 1, right? So that means you'll get 1. And then this guy gets popped. So now it's popped. Now you only have -3 and -5. All right. And then now you compare -3 with 4, right? -3 is bigger. -3 is smaller. So 3 times 3, it's 9. Again, you pop this guy off. And then you get 4 versus 5. 4 wins. Take this out. 5 versus 5 is the same thing. 25 and then 25. Right, so you got these guys. So now they're popped off. So essentially you get this answer right here. So that's how you do it. You get a stack and you do that. So what is the time complexity of that? It's linear of n, because all you do is you move this once, you move towards that once. And then what's the space complexity? The space complexity would be O of n, because you need the stack and also the answer array. Cool. All right. So that's pretty much it. So let's code this up. First, what do we need? We need a negative stack. Okay, so now we have a stack. Excellent. We also want our result array, which is another array. And then what do? First, we go through the lists. All right, for n in num, so you're getting all the number. And like I said before, you want to put all the negative numbers into your negative stack. So if they're negative, then what I want to do is I just want to push them into the negative stack. All right, so we push them and then we continue so that we can go through the next negative numbers. And then once you're all done with the negative numbers, then you're not going to go through here. So what you want to do once you're done all the negative numbers, you want to pop the negative stack until that stack is bigger, like the first number, or like the top of the stack is bigger than the current number you're looking at. So while there's still something in the stack, then we do this. And if the negative of the top of the stack is smaller than the current number that we're looking at, the current positive number that we're looking at, then what we want to do, we want to pop the stack and append it to a result array, right? And then after we've looped all of it, when all of the numbers are smaller, like the absolute number is smaller, then we can actually append the current number that we're looking at. So result append and 2. All right, cool. And then at the end, that's it. You just return your result and that should be good. All right, cool. So let's see. Yeah, perfect. So that's exactly what we get. Yep. And then we could try some different test cases, right? I mean, they have to be sorted. So maybe -10, -9. Let's try like all negative numbers, see if that works. Yep. All right. So as you can see here, there is a bug because it returns an empty array. The reason because it returns an empty array is because if they're all negative, then they're all going to remain in the stack, and then this for loop is going to end. So that's why we have to add this. So here what we're going to do is if we still have some elements in the stack, then we are going to pop them off and put them into the result. All right, cool. Excellent. So now let's try another test case. Excellent. So all positive numbers work. Let's just do another one where the biggest number is negative. All right, excellent. So that's pretty much it. I hope you learned something here. And yeah, thanks for watching. See you next time.